Okay, for those of you who don't know me, I'm Stefan Graber. I'm the LXC and LXD project lead at Canonical. So basically, I'm in charge of anything container related over there. Um, and, and yeah, today I'm going to talk about LXD. LXD is a reasonably new project. We announced it slightly less than a year ago. Briefly, it's a layer on top of LXC, which exposes a REST API to manage infrastructure containers. So we really only care about running a full Linux distribution inside our containers. We're not in the application container business. We actually really like to be able to run Docker, Rocket, and whatever else inside a LXD container. Our main goal with developing LXD was to really simplify the user experience around LXC, which has been a bit confusing and difficult for some of our users. So it was a good time for us to rethink everything through. LXD is designed to be extremely fast. So we do use any kind of security option that's available to us, except any kind of virtualization technology, because we want things to be fast and low memory footprint. And we believe we can achieve that in a perfectly safe way using all the security features available today in the Linux kernel. As I just said, containers are really safe within LXD. We do use user namespaces, seccomp, AppArmor, SELinux, capabilities, C groups. What did I forget? Just basically anything that any security feature the kernel offers, we are using it. The main thing when we designed that whole new user experience for LXD was to make sure that the exact same thing, which applies to a single developer on their laptop, will then be able to work identically in staging and then to production. So our command line tool is really designed to be really nice and easy to use on your own machine, but you can just as well run it against a machine, against a cluster that's running thousands of containers. That also means that you don't need to change tools within your organization. And developers and your sysadmins, DevOps, whatever we call them these days, will be able to use that stuff. So that's basically what the standard LXD experience looks like. I'm saying standard because, as we've announced a few weeks back, we're actually working with Microsoft with regard to Windows containers. So obviously, some of those layers might differ in their case. But our stock experience for LXD is we have a bunch of hosts, or if just your laptop, just one, running Linux. We run LXC, as in the LXC library on top. Then we've got the LXD daemon running there that exposes a REST API. That REST API can then be used by a few command line tools or our OpenStack plugin. Our OpenStack plugin is pretty important to us because it's really our enterprise story. Companies that already manage really big private clouds or even public clouds can start using containers for some of their workloads by just using our Nova Compute plugin. When they do so, they can then simply choose an image which is a container image instead of a VM image, and they'll get containers managed the exact same way as they would for VMs. We really strive to make it so that the experience within an LXD container is as close to possible as a VM. Obviously, we won't let you mess with the kernel or anything of that kind, but you can, things like resource limits are properly displayed in there. We make it really hard for a container to harm a container next to it, that kind of stuff. And the other thing with our design for LXD is we really wanted to make that REST API as simple and obvious as we possibly could, which means it's really simple. You can use it with curl if you want to. You could use it from a web browser using JavaScript if you want to. It also means that if you want to write your own tool to drive a bunch of LXD hosts, well, it's pretty simple for you to do so. You could use our client library in Go or Python binding we're also maintaining, or you can just write your own and doing straight REST. Now, a few things that LXD isn't. as I said, it's not another virtualization technology. We do work with hardware manufacturers. Unfortunately can't say much more about that, but we are working with those guys to try and make containers as safe as possible using new hardware features. We're not looking into using virtualization technology for that, like some other container runtime are at this moment, because we believe that doing so would significantly lessen the advantages of containers by making things way slower and using much more memory. It is not a fork of LXC because, well, we are the exact same team doing both, and LXD is really just using the LXC runtime through the upstream LXC Go binding. Any new feature we need for LXD, we'll implement in LXC first and then use it through that. And it's not an application container manager. We really need to stress that. Our intent is absolutely that you can install and run Docker and Rocket inside a LXD container. LXD is really meant as a drop-in replacement for a VM. So enough boring slides and stuff. Let's actually look at what that thing looks like. First thing is gonna be whether we can read that stuff. Okay. Oops. Didn't mean to do that. Let's try that again. Okay. Maybe make it a bit bigger. And I guess I need to move that window up too, so that it actually fits on that screen. Where's? Come on. There we go. And no idea why that showed up again. Seriously? That's gonna be fun. All right, that should be good enough. So, well, the first thing you would probably want to do with there we go. With LXD is just look at whether there's already any image in your image store. And I realize that looks like shit, but that's because of the resolution there. So currently in my local LXD, I've got a bunch of images. We see I've got 2 Ubuntu images, one of the latest long-term support release, one of the current development release, and I've got one that doesn't actually have a name, only a description, which is CentOS 7. I'll get back to that specific one a bit later on. Starting a new container is as simple as just launch name of the image, name of the container. There you go. You get a new container called first, which is running. If I list containers, we can see it running here, the first on that list. I can get extra information on that specific container. We see it's running, it's got an IP, what's the init PID process in there. And I can look at its config, which is mostly boring auto-generated stuff right now because I've not actually done any configuration for that specific container. Basically what we see is what image has been created from, so the full hash of that image, the MAC address, and the current ID map, which is details for user namespace configuration, really. Now, more interesting things we can do with that container, obviously we can run command inside it, which is failing due to internet being down. Okay, so if you want to run a command, you can do so with just passing LXC exec container name, then the command. I could do that with, say, bash, and then I get inside the container and can run whatever I want in there. The demo I wanted to do, which is not quite possible due to internet not working right now, it was updating that container and then making a snapshot of the updated container. So I'm going to pretend I've just updated that container. So we can snapshot that container that's called first and make a snapshot called upgraded. There we go. Now, let's say something bad happened in the container. That usually qualifies. If I go in there, I see I have no name, and obviously it's gone. That's kind of bad, but we can fix that by just restoring the container. from the snapshot, at which point things work again. And that's all very nice. Now, I just need to fix my windows here. What we can do too is, because LXD is entirely image-based, we don't do any kind of stacking or anything like that because we have really, our images are meant to be pristine distribution images shipped by the actual distribution. But you can publish images of your own container for internal distribution, like installing a bunch of extra packages, that kind of stuff, and then distributing that if you want. So one thing you can do is publish that snapshot I created earlier, which is called upgraded, as a new image called say, upgraded Ubuntu. Obviously, it's not due to internet, but let's pretend it is. That specific, what's actually going on right now, and that's pretty slow for obvious reasons, is it's actually, so it immediately created the image using the current backend driver, which in my case is BurrowFS, which is pretty much instant. But then it needs to actually compress that image as a tarball, which can then be used for distribution between LXDs. Since we support a bunch of different file system drivers, we need to be able to transfer things in a generic way. In our case, it's a compressed tarball. The hash of that compressed tarball is the image hash, which is why it's not instant to publish, since we need to actually have it compressed first. So we see it's got a nice long hash here, but since I also passed an alias name, it's going to show up as a much more readable entry here, which is the last one on the list. It shows us upgraded Ubuntu. Now let's say I would just delete that first container because it's not really useful to have around anymore. I can launch a new container using that new image. Let's call it second. And there we go, container's running. Now, because LXD is managing containers, we can play with any of the usual nice container properties, which means that, say, if I lose network in that container, I can obviously still access it just fine, even though it's across the network, but it's across the network to LXD, not to the container itself, so it still works. I can also easily pull any file I want from that container, say syslog in this case. I can list what's in that syslog, and that's all fine. And have fun with that second container, I can remove it. There we go. Okay, now the slightly more interesting stuff. And just checking whether Wi-Fi will actually reconnect, because if it doesn't, that's going to be slightly less fun. Apparently it says it did. Okay, well, let's see whether that works. So, as I said, the command line tool we've got can manage either your local machine, as I just did, or any or deal with remote resources. So by default, you only have a single remote in there, which is your local LXD. But you can add more, and one public one we've got is images.linuxcontainers.org, which contains a lot of distribution images. That's going to look really bad on Projector, I suspect. But as you can see, we've got a few of those. Now, to use one of those, all you have to do is launch with the name of the remote, so images in this case, colon, and then the image name. So I'd say one start CentOS 7 as a third container. There we go. Obviously, it didn't actually download that pre-cached because I was expecting Wi-Fi to be slow. The image itself, it will be about 60 megs, so it's usually pretty quick. But in this case, I prepared that a bit. And if we get in there, we see it very much is a CentOS 7 image. Now, I can delete this one. There we go. That was dealing with a read-only remote, which is an image server, just pulling an image from it. It's usually more interesting for people to deal with proper remotes, as in LXD remote. What you can see here is I've got two containers running on my system, one called LXD01, the other one called LXD02. Those are current Ubuntu development release containers that are then running LXD inside them. So I'm doing LXD within LXD because I don't like VMs, so I figured that would be easier. And to interact with those, I can simply do LXD remote add name and then the IP in this case, so that's 52. Yeah, if I put the loss in the right place, it works better. So it asked me whether the certificate fingerprint looks fine. I'm going to assume it does. And then asked me for the trust password. So I did the first one. Now I'm adding the second one. There we go. So if we list remotes, we see I've got the images remote I did earlier, local, and then LXD01, LXD02. You can set what is the default remote. By default, it's local. The default remote is the one you don't need to ever prefix. So if I was to set LXD01 as a default remote, if I do Lexi launch Ubuntu blah, it's going to create a container called blah on LXD01. And if I want to interact with the local server at that point, I need to do local colon blah if I wanted it locally. So now that that's done, I can easily list containers on those. So listing LXD01, listing LXD02, which it's all empty. Same should be true for images over there. And now what I'm going to do is use the local image we created earlier, so upgraded -Ubuntu, and create a container called fourth on LXD01. What happens in this case is the LXD in LXD01 will check whether the image hash already exists in this image store. As I listed just earlier, there's nothing in there, so it won't. So it's going to cache it first and then spawn a container from it. So if we look now, we should have a cached entry, which is there. We see just a fingerprint, no alias, no nothing. The cache entries automatically expire after 10 days since last use, so that all clears itself automatically. And then created the container from it. So if we want to get a shell inside that container, we can simply do LXD01 fourth bash, and there we go. We're inside that container. Now, more interesting things is obviously we can make copies of containers. So I'm going to copy fourth into fifth. So we can see it's there. But then let's say, oh, yeah, I didn't actually mean for it to be on that host. I prefer it to be on LXD02. So then I can Lexi move LXD01 colon fifth to LXD02 colon, which is going to just move it across. I could do LXD colon sixth, and it would rename it in the process too. So what it's doing now is using, depending on the file system, figuring out what's the best way of transferring stuff. So either doing straight rsync or doing butterfs, send, receive, that kind of stuff. Moving the container across. So now if I list it, no more containers on 1, and it's on 2. And then I can rename it just for kicks. At which point we see it's called container.camp now. And then I can start it on this one. There we go. And I can get a shell inside it. There we go. So that's basically your playing with LXD 101. As I said earlier, playing with the API is reasonably simple, except it's going to look a bit odd on that screen, I suspect. But that's basically what you need to do. So curl using a SSL client certificate, then you just talk to the API endpoint. The API endpoint, the main API endpoint just lists a bunch of nice properties, IP addresses, what's the version of kernel and LXC and all that stuff. You can then list all containers by using /containers. So we see fourth is listed there. We can get more details on fourth itself by querying /fourth. We see its IP addresses. And if you want to grab a file from it, then you can access /files and then pass the path of the file you want. In this case, it's a host, and it just pulls it. So it's really quite straightforward. We don't need any fancy headers or anything. It's just plain HTTP. And that's it for the demo. So if we can go back to the slides. There we go. So what's coming up next in LXD land? So we are working on on our Nova driver to make it up to par with LXD itself, so supporting every single feature we've got, including things like live migration. I didn't show live migration because it depends on really specific kernel and user space and libraries and a bunch of other things. It's really very much work in progress, and I couldn't get it working earlier. It's tricky, but it's something we've made significant progress on over the past 6 months, and we expect to have it production ready next year. So I said safe-line migration, we're working on that stuff. We're also adding support for some SDNs and for new storage backends. I'm currently working on ZFS support. LXD has been published in the Ubuntu core store as of last week, so you can install it on any Snappy system. We contributed LXD support to Juju, so very soon we expect LXC to be replaced by LXD inside Juju. And long-term support for LXD will come with Ubuntu 16.04 LTS, at which point we expect to have 5 years support. That's quick recap. We can start taking any questions at this point, if any of you have any.
Any questions, very quickly? All right, I'm going to call it then, but you can also catch Stefan at lunch. So thank you very much for Stefan.
Thank you.